Hello, everybody, and then a great Java developers, any application developer around the world, and then thanks coming back, and then welcome back, and then who already joined the Java conference, Java Champions conference last week and earlier today, and then yeah, we have a great Java champion today, the Eric Andrea, my friend, my fellow, my coworker from Red Hat. And then he's going to talk a little bit about today or test-driven development. Sorry about that. Test-driven development is very easy than you think, which I'm
That's
correct.
right. Yeah,
All right.
it's
So
so easy. Your mom could do it.
perfect, awesome. So I'm going to say my word, and then I'm going to hand it over to Eric. Go for it.
All right. Thanks. I got to pull up my screen here. Here we go. Excellent. All right. Thanks, everybody. And thanks for taking some time out of your day, morning, evening. I'm on the East Coast of the US. So for me, it's it's about lunchtime, but I took an early lunch. So thanks for spending a couple of minutes or an hour or so with me. Today, I'm going to talk a little bit about test-driven development and how easy it can be. So there's really no reason to do it. If you're not familiar with me or know who I am, I've been doing software development for about 25 years or so. I spent most of my career in financial services before joining Red Hat. I had my 6-year anniversary last week. I became a Java champion last year, and I contribute to a lot of different open source projects, Quarkus, Spring, LangChain, and a bunch of others. I help out in my local area. I live in the Boston area, so I help out and help organize my local Java users group. So I'm one of the board members, and I help bring in speakers to do sessions like this, where we bring together our local community. And I do like to be on my boat. You can see my picture up there in the corner. That's everybody has their happy place, and that's my happy place. I love to be out on the water and just be happy. I have written a book. It's free. I have a whole nother talk that goes along with this book, but it's something I did a year or two ago. And if you're looking there's a bunch of different talks that I do. I'm pretty busy the upcoming. I was in Canada last week. Thank you again to Ottawa and the Montreal Java users groups for hosting me last week. I'm here with you right now. And then next week, I'm going to be in Stockholm at JFocus. I believe I'll be with my friend Dan as well. And I'm doing a talk with Oleg Shelejev from Docker about testing non-deterministic things. So kind of a little bit of a spinoff from this talk, but with a little bit different of a focus. So thank you. And Dan's going to keep me honest with questions, because unfortunately I can't see the questions as they roll in. And I'm also going to apologize up front because I'm having a little bit of work done in my house, and there's somebody upstairs hammering and banging and sawing, and I'm going to try my best. If I have to, I've got these noise canceling headphones and I'll put on and see if that helps. But unfortunately, they called today and scheduled, and they're like, yeah, we're going to be here this morning. So this is live and in real time. It's not pre-recorded. So apologies if that starts to interfere, but I'll do the best that I can. So let's get rolling here. So why are we here? Why did you decide to come to this talk? So if you think about the end goal for us software engineers is to put things into production, right? Because if you spend time and you write all this code and it never goes to production, it was just wasted effort. It provided zero value. Which at the end of the day is wasted money for your organization. But to get to production, you need to know that your code works. So I know for me, like when that pull request gets merged, or I'm working on a new project, or even a project I've been working on, my code gets in and I see my name in the release notes. It's like, yeah, awesome. But the question is, how do you get there? How do you get to that point? I know as a developer, because it builds, does that mean it can go into production? I know we wish it was the case. I always wished, especially in financial services, that was the case. And we think it all the time, but in reality, we know we can't really do that. We can't go to production without knowing for certain that the code or the application works, especially in the days of microservices, if the application is part of a larger distributed system. Because if ours goes down, it might cause cascading failures and might bring the whole thing down. But if you do that and you do put things to production, I don't know if you can read the slide, but this was a screenshot somebody took at DevOps UK last year that talks about introducing new bugs, right? So you go to fix a bug, you put it into production, maybe you don't test it thoroughly, and then you end up with more bugs. And I don't know if that's ever happened to anybody else, but I know it's definitely happened to me. But we try to explain it by saying, hey, it's not a bug, it's a feature, or the user's not using it right, right? It's something that we all do to try and explain it. But really, the real and the best way to get around this problem is to be able to write tests, right? And it's one thing to write tests, but it's another thing to actually run the tests, right? Because if you write them and never run them, then that's just wasted effort. And you want to try and run it before your code makes it into version control. Because I don't know about you, but when that whole shift left initiative started, God, I don't remember, 10 years ago, was it about that time, 10, 11, 12 years ago, being able to move your testing and move your code quality to the left, because it's always easier and less expensive to fix the bugs before they even get into version control, or before it gets to production. But the sooner you can find them, the easier it is to fix. But what you typically find, I know for myself, you start writing more and more good tests, and in air quotes here, good, you start to find that tests get flaky, right? Sometimes they don't pass. So what do? You disable them, right? Yeah. So because they don't disable and you don't have the time to spend in that sprint trying to figure out, is it the test that's the problem? How do you test your test? Or is something broken in the code? Or this is a test that usually fails, so you just start disabling them because you want to see green on your CI. And then you start to smarten up and say, hey, I keep starting to, as I'm building these tests, I start disabling more and more of them. So if I keep disabling them, well, why do I write them in the first place? And it becomes this vicious cycle. So it brings you kind of back to the beginning of my talk here. And why am I writing them if all they do is fail? But we write them to prove that our code works. And I don't know about you, but when I've been working on a couple hard problems, if I start writing a test, sometimes, and a lot of times, it actually helps me visualize or figure out what the problem with my code is. Just writing the code, and then if it's an application, starting it up and using it or debugging it. Sometimes I find it's easier to actually write the test that tests what I think the expectation should be, and to help prove that code should work. The other thing I find too is if I have a hard time testing it, it's probably not a good design in the first place. Like if I'm struggling to figure out how do I even test the thing, then I probably need to rethink the thing too, right? And I know I've encountered this situation too, where I write some code and the code works, and maybe I put it on the shelf for a week or two. I do a lot of context switching, so I work on a bunch of different things, and then I come back to it, and it works like when I start the application up, but I kind of scratch my head, and it's like I have absolutely no idea how or why the code works. And so then I'd write a couple of tests and help me understand. Or I'll ask ChatGPT. You might even do that. You ask ChatGPT or your favorite offline AI model what your code does to try and explain it to you. But if you had the tests, I find reading the tests, I probably spend a lot more time reading code than I do writing code. And when I read the tests, even for code that I've written a year ago, it comes back to me and it makes sense as to what the code under the test actually does. And so now you're probably thinking, oh God, I've already got enough on my plate. I write as few tests as possible. But what if writing the test could be fun, or if there were some tools or frameworks or whatnot that were out there that helped you make it really easy. And there was actually a quote, I found this, I didn't actually go to DevOps UK last year, but I saw somebody posted this screenshot where somebody was talking about test-driven development and how it can be fun. And I'm actually going to read it, this picture to you. So it says, TDD is fun. It's like a game where you navigate a maze of technical decisions that lead to highly robust software while avoiding the quagmire of long debug sessions. With each test, there is a renewed sense of accomplishment and clear progress towards the goal. And I know for me, I tend to to feel that way as well. Each time, especially when I'm building something new, as I'm writing the tests and the tests go green, I start to feel like I'm closer to the end or closer to done. And so, yeah, so you're probably like, yeah, this guy is like, he really likes tests. He must have something wrong with them. So what I'm going to do is I'm going to prove it to you. But first off, before I prove it to you, I like to use a visual. And if you're not familiar with what this is a triangle, right? It's a triangle. But I like to call this, or it's not my thing. This is called the testing pyramid. So the testing pyramid provides like a nice visualization to talk about different kinds of tests and the value that those tests provide. So at the top of the pyramid, you've got your end-to-end tests. So these are the ones where you have to get every team in your organization on the same page on the same day on the sixth Tuesday of each month when there's a high tide and a full moon with all the data in line, and then you deploy everything into some environment and everything is there and you can run a full end-to-end test. So, I know there's no 6 Tuesdays in any given month. So it's kind of a joke, but it's a Herculean effort to do some of this. But the cost is expensive, but it gives you really high value because if things break or if things work, you've got a pretty good confidence that the system as a whole is going to work. Whereas at the bottom of the triangle, you've got your unit tests. And I don't know about you, but I've written plenty of unit tests in my life where the CI passes, everything is green, and then you push the thing to production and all hell breaks loose, right? And things just start failing. So unit tests are good because they can find things where maybe a subcomponent of something doesn't work. Maybe, in the case of like a fire alarm, for example, maybe the buzzer doesn't work. And so a unit test for that would be really good, but it doesn't give you a whole lot of confidence that the system as a whole is actually going to behave properly when everything is deployed. But unit tests are pretty easy to write. They're pretty cheap to run. So you probably write lots of them because the sooner you can find issues, the better. And then you've kind of got what's in the middle that we just apply a label called integration tests. It's a little bit more than a unit test, a little bit less than an end-to-end test, a little bit more realism, a little bit more effort, but still not at the same level as your end-to-end tests. But if you think about it, over the last couple of years, there used to be this real distinction between unit and integration tests. I remember, back in my early days, if you had said, "Oh, I'm going to talk to a real database," or "I'm going to make an actual HTTP request to your application," people would consider that an integration test. But a lot of the modern frameworks and tools and technologies, Spring, Quarkus, test containers, things like that, have started to blur these lines a bit. So we can start to get a little bit more realism for the cost of a unit test. And so, kind of where is your test an integration test, is a unit test, that line is kind of blurred. And this is where I think over the last 10 years or so, test-driven development has gotten a whole lot easier because you can start to be more realistic and you can do it more in real time. And so for anybody who's interested, I have a whole talk that talks about distributed testing and, unit tests are green, but everything's in production, how to stop that. You go find my speaker deck or, YouTube. I've done this talk with Holly Cummins a bunch of times about testing. So today, I think that's about it for slides. I'm going to focus mostly on code. So what I'm going to build, I've got about 45 minutes. Maybe I can do it, maybe I can't. But we're going to build an entire application. We're going to do it from scratch, and we're going to do it using a test-driven development approach. That being said, you kind of have the testing purists, and then you have the testing realists. And I don't know if you can see my hands here. I'm Italian, so I talk with my hands. You've got the purists on one side, the realists on the other side. I kind of fall in the middle. Like in true test-driven development, you don't touch a line of code until you've written the tests first. And in realistic sense, yeah, that's good, but it doesn't always happen. For me, the kind of going back and forth and using some of these tools, these AI tools and the IDE tools, as well as TDD, when you start building something, you generally have an understanding, or somewhat of an understanding, I hope, of what it is you're building. So you've got some mental models and some ideas in your head as to what you want and what you're going to do. So, not necessarily, every single time starting from test before you write any code, but you'll kind of see as I go along. And so what I'm going to build is this this Quarkus application that exposes a REST or a couple of REST endpoints for getting and persisting pet information. It uses Hibernate, talks to a Postgres database, and then it additionally listens on a Kafka topic. So as requests from other systems for adoptions of pets come in, if we have pets that meet the criteria for adoption, and we have, someone wants a rabbit, for example, and we have a rabbit that's available, we can make that adoption, and we can store that adoption record in the database, as well as put that message back on another Kafka topic and send it back. And so there's the pictures that are up there, those are actually my pets. So I've got 2 cats. The big orange one is big fluffy. He's big and fluffy, and but the little one is the one that's in charge. And then the dog on the left is Maxie, and she's sleeping over here on my floor. So without further ado, so Dan, if you want to drop the link in the chat there, there's a QR code and there's a link to, if you want to just skip ahead and not watch me code this, the completed version of what I'm going to do is there. So. All right, and someone speak up, or Dan, speak up if you see anybody in the chat that says it's too small, because I can't see the chat. So I'm going to start completely from scratch in my favorite IDE, IntelliJ here. And I know people say you're supposed to go to light mode when you do presentations, and I just can't stand light mode, especially because I customize all my colors. And if I went to light mode, you wouldn't be able to see anything. So I'm going to start with a new application, and then I'm going to. Let's see, I'm going to pick REST Jackson because I need Jackson marshalling. I'm going to pick Hibernate ORM with Panache, and I'll explain what Panache is in a little bit, but it's essentially, if you're not familiar with it, an abstraction layer that sits on top of Hibernate. I'm going to pick I need a Postgres driver, so my JDBC driver for Postgres. I'm going to pick, I like OpenAPI because I don't like curl, so I want to be able to interact with Swagger UI and whatnot. I'm going to add my health endpoints because you should always have health endpoints. I'm going to add the Jib container image just in case we decide to build container images. That'll make it easy for me. And then I'm going to hit create. And of course, it appears on my other screen. Boop, boop, boop. All right, let's move this over, close this, make this a little bigger, turn off all these notifications. All right, so I'm gonna go into the POM, and there's a bunch of stuff in here that it already did. I'm gonna add a couple more things. Some extra test dependencies. So I'm gonna add, I like to use mocking and I like to use Mockito when I do unit test mocking. So I'm gonna add that in here. I'm going to add in AssertJ as my favorite testing library. If you're not familiar with AssertJ, I highly suggest looking into it. And I'm going to use Rest Assured for testing my REST layer. And then the other thing I need to do is go into my properties file and add a few properties in there. So I'm adding just some stuff around the continuous testing that I'll talk about in a little bit, and changing my log levels and debug and whatnot. All right, so at this point, there's no actual code here, but if I run this, so I'm going to run Quarkus, and if you're not familiar with Quarkus, Quarkus ships with this thing called the dev mode, which will run your application in a live coding mode so that you can make code changes as it goes. And if you look at what you see here, excuse me, Hibernate ORM is disabled because no JPA entities are found. Well, that kind of makes sense because I don't have any code yet, right? But you can also see dev services for default data source Postgres started. In my POM, I had a Postgres database driver, but I didn't configure it. So Quarkus will automatically start a Postgres container for me. And if I just open another terminal and I do, podman ps, you can see that there's a Postgres 17 container running. The other thing you kind of see here is this no test found. Well, that makes sense as well because, again, I don't have any code, so I haven't done anything. So let's start from scratch. So I'm going to start with a new package, super interesting, that example package, and then I'm going to create a pet class because I kind of, the application is a pet adoption, so I probably need, some pet domain object. And I'm using a class and not a record here because this is going to be a JPA entity, and in JPA you can't have records as top level entities. So I'm going to add a few fields here. So I add my ID, name, kind, adopted by. I'm going to add a few annotations here. So it's an entity, and then I'm going to define the table called pets. And you see just the Jakarta persistence. And then I'm going to add you could say, I'm going to add getters and setters. You could say, oh, you could just use Lombok and not have getters and setters. And I tell you that Lombok and I do not get along with each other. We've tried to have a relationship in the past, but it just hasn't worked out. So Lombok and I don't get along. So I'm going to add a few constructors for being able to instantiate this object in a bunch of different ways. And so now our entity class is good. If I go into my source main resources, let's add some sample data via an import .sql. There we go. And again, they should never let developers name things, right? Fluffy the cat, Herman the dog, and Cutie Pie the monkey. I'm not good at naming things. All right, so now we have an application actually up and running. Again, still no tests found. So now let's start creating some tests. I don't even have a test folder here. So new directory, source test Java. I'm going to say new package, example. And let's start here with, I'm a bottom-up person just in general. I tend to dive into the weeds easy. So I'm going to start from the bottom of the application up. Where is it here? So I'm going to start. I know I need some kind of repository layer. So I'm going to say pet repository test. Right? It's a Java class. It actually doesn't need to be public. And this is an @Quarkus test. Right? So now when I save this, it still says no tests found. Nothing's happened because I still don't have any tests yet. So now let's add some scaffolding in here. So kind of the way I like to do tests. And the other thing I'm going to add here too is this @test transaction annotation. So because we're working with the repository layer, Quarkus is automatically going to give me a real Postgres database. And I don't know if anybody's ever been bitten by you write a SQL query, you run your tests in like H2 or an in-memory database, and then you deploy it to an environment and your application breaks because you've got something in your query that worked with H2 and not Postgres or vice versa, or isn't standard ANSI SQL. So it doesn't translate between the databases. So being able, kind of one of the first things I always like to do is get as close to my production environment as possible when I'm doing my tests. So that way I can flush out any kind of potential things that may happen. And so in this repository, it's actually going to start a real Postgres database, and everything in that import, that SQL that I created is going to be there as records in the database. It's going to create my schema for me. So test transaction says that every test that you run is going to run in an isolated transaction, and regardless of whether the test passes or fails, it's going to roll the transaction back. I could put the annotation on every method and it would accomplish the same thing, but if I want every test to have it, you can just put it at the class. And then the pattern I like to follow is I like to start everything from a clean slate. So I'll delete everything from the repository, make an assertion that it's empty. Then I'm going to persist something, kind of set the state of what I want for each test, and then perform some stimulus and do some assertion. All right, so the first thing I need here is I actually need to inject the repository I want to test. So I've got a pet repository, and it's red because IntelliJ says it doesn't exist, right? Which kind of makes sense. So I'm going to use the IntelliJ assist, and I'm going to create that class. So because we're using Quarkus, we're using CDI. So I'm going to make this application scoped so now it's a bean that's registered in the context as a single instance, and this is going to implement. And this is kind of where I talked about Panache a little bit. So this is if you're familiar with something like Spring Data JPA or even the new Jakarta data stuff that's out there, it's being able to apply this repository pattern on top of Hibernate. Don't have to do it. It just makes it easy because now I get, if I look at, all the methods that are inherited, I get all these extra methods, like all my CRUD methods for free. So, all right, so now I've got that repository class. I'm going to move my code over to the right and keep my tests over on the left here. So you can kind of see it side by side. I'll push this away so that it gets a little bit bigger. And you can see, I added 4 tests here, which, they all pass. So do we stop? The whole thing behind TDD is, you start writing tests and you stop when they're green. Everything is green right now, but, it's kind of a joke, right? Because I don't have any implementation for any of my tests. But what happened under the covers now is Quarkus and the continuous testing detected that I had tests, and it's now running them in the background. And it has an understanding between the relationship between my code and my tests. So as I start writing my tests or as I start modifying the code, it'll rerun the tests that are affected by that code in the background. So now we can start. I can say pet repository, delete all, and then I can do assert that, and I always use this. Don't kill me because I use this. From assert J, assert that repository. And this is count is 0, right? And then I'm going to say my repository. I'm going to persist a new pet, and this is going to be Fluffy the cat. Right, and then I want to assert that. So now I need some kind of retrieval, because if you think about, I'm going to be doing adoptions, and so the adoption is going to come in and say, hey, do you have a cat or a bird or a monkey or bunny, whatever that needs to be adopted. So I'm going to need to be able to find that I have at least one pet of a particular kind. So I can say this pet repository find pets by kind, and I can say cat, right? Which we'll get to the implementation in a second. So now I can come in here and let's just actually create it. So I can say create this method and use IntelliJ. Okay, but I don't want it to be Boolean, so it's going to return an optional pet, and not a cat. It's going to be kind, right? Import. You think with all this AI stuff, it would know what I want to do. So assert that. It's not null. It's not null. And oh, actually, instead of optional pet, it's going to return a list of pets. I'm sorry. So a list of pets. So find all the pets by a particular, give me all the cats, give me all the dogs. So in this case, because I only have one, assert J makes it really easy. So I can say a single element, and that will assert that there's only one element, and that one element is not null. And then I can say I can extracting pet that get name, pet that get kind, contains exactly Fluffy the cat, right? And as soon as I hit save, it's not compiling, right? Because this code doesn't compile yet. Turn null, right? And now my test actually runs and it fails. All right, so let's go on to the next. We'll finish with our test, and I'm going to apply the CAP pattern, CAP, that we're all familiar with, which is called copy and paste. So the kind of the first two parts of each test is to clear out the database from all records, right? So we'll do that for all 4 of our tests, and then we'll combine. So if I don't persist the pet, right? So if I say assert that find pets by kind, it's still not null, right? But it's empty, is empty, right? And if I save, now that test fails too, and we'll come back to that. So now I'm going to do adoption. So again, with adoptions, there's 2 scenarios that could happen. I could go to do an adoption when the pet exists and when a pet doesn't exist, right? So if I'm going to say persist some pets, I'm going to say this pet repository persist. I'm going to say new pet Fluffy the cat and a new pet Herman the dog, right? And now I can say assert that and adopt pet if found, and I'm going to adopt a cat So I'm going to say I'm just kind of making this up along as I go. And now I'm going to use IntelliJ to actually create this method. And instead of a Boolean, it's going to be, this is my optional pet. And this is going to be the kind of pet and the owner. Right, so now that returns null. Now I can come back over here and I can say is not null, right? Because I don't want it to be null. And because it returns an optional, assert J can assert, if I just call the get method, it'll assert that the optional thing in the optional is not null, and it'll actually return it. And then I can say extracting, and then pet get adopted by, nope, get adopted by, contains exactly Fluffy, the cat was adopted by me.
Hey, Eric, there's one little question just pop up.
Yeah, what is it?
Yeah, question was, don't you want to make the test pass first and then also J as a lot of readability to test for the less repetition?
So say that again.
Don't you want to make that test pass first and then also J as a lot of readability to test for less repetition?
Yeah, so I think the question goes to like, do I, I go one test at a time, I work on this test, it fails, I go make it pass. And you could, it's just by choice that I did it this way. I could go this way and then go over here, and then maybe it passes first and then it fails. I don't know. I just decided, and for really no rhyme or reason, I just decided to do it this way. I don't think I made a conscious decision.
Gotcha. Yeah, thanks for the answer.
Yeah. Plus, I kind of knew the use cases I was testing too. I mean, I knew the kind of the 4 different use cases. So while I was in the test, I figured I would just do the test. But
cool.
You could have done it the other way too. All right. So now I'm going to say my repository persists, and I'm going to persist a new pet, but I'm going to have one that's already. So I need to have a case where I want to adopt a, say in this example, a cat. Even though I have a cats and dogs, I'm more of a cat person than dog person. So I already have a cat that's adopted, and then my new pet, Fluffy the dog. And now I can say assert that I want to adopt. I don't want to adopt Fluffy. I want to adopt a cat. So this is not null, right? It never wants to be null. I don't like null, but there's no pet there. So I can use assert J to assert that the optional is empty. And so now I've got 4 tests and they're all failing. You can see at the bottom here. So now I can actually go and implement my repository layer. So like I said, if you look at there's already a ton of stuff that's under the covers here in my implementation. So one of them is shorthand, where I can say I want to list, which returns a list, or I can give it the query. And so the field I want to query on is the kind field, and I want the value to be the kind that's passed in. And if I save it, now let's see, now it reran, and now I've only got 2 test failures. So the first 2 tests, which have to do with the getting the pets by kind, both when one exists and one doesn't, now pass. So on the other side, now, if we want to do this adoption, we can say my var, I have a pet, and I can say equals. So how would we find? So I have this find method. How do we find a pet that doesn't exist? If you think about your schema, you've got this adopted by field, right? So you could say where my kind equals my my first parameter, and my adopted by field is null, right? So there could be more than one. So there could be more than one cat that's not adopted, or more than one bird that's not adopted. So what I want to do is I want to say order by, I just want a random one. So I'm going to order it by random, which, by the way, is a Postgres specific function. So if you tried to run this with H2, this would actually fail, right? And then I can say find, and this may give me more than one. So I can say I want a page. I want the first page of size 1. And because I need to update, once I find one, I need to actually perform the adoption. So the other thing I need here is I need transactional, right? This is a transaction. So I need to actually lock that record. So I can say with lock, and we could have a whole conversation around lock types and optimistic versus pessimistic writing. For now, I'm just going to do the brute force, and I'm going to return and make it a pessimistic lock. And I want to return my first result optional, right? Because now if I find that pet, I now have an optional. I can say pet.if present. I can say p set adopted by the owner, and then I can say persist p, right? And then I can return my pet. And when I save that, what do I get here? It still fails. No argument for ordinal parameter 1. Oh yeah, I didn't put kind in here because I declared the parameter, but I never actually passed the value here. So kind. And then when I save, now I'll form my test pass. And I'm good. So now I've got my persistence layer. So now let's create a REST layer. And so for with the REST layer, I'm actually going to start from my tests. So I'm going to start with a pet resource test, right? And again, it doesn't need to be public. And this is that Quarkus test. Right. So now, when I'm unit testing my resource layer, it probably needs my persistence layer. So I can say inject mock my pet repository, right? And then let's put a couple skeletons in here. So I have an operation where I can get all the pets. I have another operation where I can get all the pets by a particular kind. And then I have an operation where I can get a pet by an ID. And I have two cases, one where the ID's where the pet's found and where there isn't a pet found. Right. So I've got those 4 use cases. And in terms of REST, there's a bunch of different ways you could do it. But the way I chose to do it, the get to /pets is what gives you all the pets. And then I have a get to /pets with an optional query parameter. And so if there's a query parameter, then that becomes kind of like my filter. It's not the only way to do it. You could do it a bunch of different ways. You could have a post with a query object, a body and whatnot. So there's lots of different ways that you could do it. And then I have a get to /pets / whatever their ID is to get a pet by ID. And if it's not found, it returns a 404. And again, we could have a conversation about 204, 404 another day, and I could convince you why 404 is the right answer. But again, it's not the only way to do this. It's just the way I chose to do this. So what I'm going to do here is I'm going to say, hey, I'm going to use Mockito when my pet repo, I already have a method that knows how to get me everything in the database, right? So if I import that, then I can return, right, a list of new pets. One, and I've got Fluffy, my cat. Right. So now I've set up my stimulus, and now I can say I want to do a get to /pets, and this comes from rest assured. Then my status code is a 200, right? And then I can say my content type is JSON. I like to use constants, content type .json. And then I can do some body assertions. I can say my body has, $size is 1, and this comes from the Hamcrest matchers, right? And then I can also say body, and then so my first, entry $name is Fluffy, and I can say body, and the kind is a cat, right? And then body, first body, adopted by is blank or null string because it's not adopted, right? And then I can, some people like to do verification. So to me, sometimes mock verification is a good thing. Sometimes it's just, in my opinion, it's just extra noise that makes your test too brittle. So I tend to use it on a case-by-case basis, but I'm going to use it here just to show how it's used. So I could say, verify that the list all method was called, right? Import the method, and then verify no more interactions with that repository, right? And now I save it, and now my test fails, right? Because obviously I haven't built an HTTP endpoint, right? And so again, the same conversation that person asked, should I go implement this now or should I do the rest of my tests? Either one works, but what I'm going to do is rather than watch me type again, I'm just going to wipe these all out, and I'm just going to give you the implementations of the rest of them, right? Yeah, and of course it doesn't remember. I've done this, a million times and doesn't remember my imports. Right, so that need to import that. Need to import response, and now I think I'm good. So when I save, now I have 4 failing tests. So I could do something similar here. I could go create a pet resource class, but what about some of this AI stuff? I don't know who uses some of these IDE-based AI tools, but I know I'm kind of cheap and I don't like to pay for stuff. So JetBrains was gracious enough to give me like a year subscription to the JetBrains AI. I've played with the new free GitHub Copilot, but I kind of ran out of the free tier after about a week. So I don't think that would work right now. So using the JetBrains AI Studio, I can say, hey, wouldn't it be nice if, oops, there we go. There we go. Now it's just a little slow. So wouldn't it be nice if it could actually give me the implementation, right? But I have certain, those who know me know I'm kind of OCD. I like things a certain way. So I could ask it and go back and forth with it a bunch of times, but instead I'm going to ask it to create something for me. And, create a Jakarta REST resource class that satisfies all the tests in the provided test class. It's including this pet repository as input. Actually, I don't want the pet repository. I want the pet repository tests, right? Or the pet resource tests. So create a Jakarta REST resource class that satisfies all the unit tests. And then I have some constraints. I only, there's lots of different ways in JAX-RS or Jakarta RS to do this, to create, especially where you've got like this query parameter and filter. There's kind of a way that I like to do it. I don't also want it to throw any exceptions. You could do 404 by throwing a not found exception. I don't want to do that because exceptions are expensive, and I can explain that another time. And I don't want it to create extra variables that I don't really need. And other than that, I want it to do constructor injection and not field injection. If I have input parameters that are kind of optional, then model them as optionals. And prefer using mapping functions with the options rather than like is present then get, because I see that all the time. And then in JAX-RS, you can return the response object that's kind of generic, and I prefer returning like an actual POJO rather than the response object. And so here's the thing. So let's see what it does. So you might start to ask, and I can't see the chat, but is there, wouldn't it be faster just to create the class yourself? Like, and in my case, where I'm someone who's very familiar with JAX-RS, and I've, as you can probably tell, I've gone back and forth with the prompt a bunch of times and tuned it to get it to do what I want it to do. Because like everything in AI, talking to an AI is like talking to a teenager. I have 2 of them, so having to craft exactly what you say to extract, the exact response you want them to give you, it can be part art and part science. So for me, I probably could have written the class faster than it took me to go back and forth and create that prompt. But for somebody who's not familiar with Jakarta RS or just, kind of learning or whatnot, this is probably something that would be really helpful and really powerful. So let's see what it did. So I'm going to have it create the file from that snippet and hide this over. And so now I have, and so it actually called my file name pet resource controller, but it called the class pet resource. So let's fix that. Refactor, rename. So it's just going to be pet resource. All right. And so what did it do? It has the path test/pets produces application JSON and generates the contract. Actually, all my tests pass. So that'd be like, I'm going to be like shocked if it actually did this first try. And I have my get, here's my query param, has the kind, pet repository. Yep. So here it threw an exception. So it did something I didn't want it to do. So yes, my test passed, but I'm just going to change it a little bit. So instead of an exception, I'm going to say return the response object. So find by optional, I want to map that to response okay, or else get response.status 404.build, right? That's how I wanted it to be, because there's lots of reasons why, and I don't have time to deep dive into that, but I don't want it to throw exceptions because exceptions are expensive. I want it to flow and return actual objects rather than have to go into exception handling. And so, oops. And now all my tests pass and I'm good. So I've got a full REST layer. And so now if I want to go, so in my console here, I'm going to hit the D key. And of course it opened on my other monitor. Bring it over here. So when I go to the D key, it opens Quarkus in its dev mode. And this is available when you're running Quarkus in its dev mode. So you can see in here, here's the what we call dev services, where it started the Postgres database. And every extension gets its own card here. And the one that I'm looking for is the Swagger UI. So now I can come into Swagger UI and I can say, try it out. Give me all pets. And so I've got Fluffy the cat, Herman the dog, and Cutie Pie the monkey. And if I want to filter it by, cat, I just get Fluffy the cat. So, you can play with the rest of the endpoints if you want. All right, so we've done kind of half of the app. I've got about 15 minutes left, so let's see how far we can get with the rest of the app. So now we got to do the Kafka stuff. So we've done our persistence layer, we've done our RESTful layer. So now let's dive into some messaging stuff. So I'm going to add, I need to add my messaging. So I'm going to say, I have the Quarkus CLI installed. I'm going to say Quarkus ext add, not messaging Kafka. So it's going to add the Quarkus Kafka extension here. And then I'm going to go into my pom.xml. And I'm just going to add a couple of extra test dependencies here. All right, so I'm adding, and I'll talk about these in a little bit. I'm adding the in-memory messaging from the messaging component. I'm adding some companion stuff, and then a waitility. So waitility is another interesting library. If you're not familiar with it, I highly suggest using it. It's really good at when you need to do assertions based on asynchronous activities, and I'll talk about it in a little bit, but it's a super awesome open source library for concurrency and testing when you have to wait for things to happen. All right, I'll go back, and you notice Quarkus in dev mode just kind of rebooted itself, and all my tests are still passing. And then I need to go into my properties file, and I need to add some Kafka stuff in here. So I'm going to add so I've got two topics, and in Quarkus, they call them channels. So you can name your channels and topics different if you want to, but by default, I have an adoption request channel that has the incoming. So there's an incoming topic for adoption requests, and there's an outgoing topic for adoption. So if an adoption request comes in and I don't have a pet that meets that adoption, then I don't do anything. And if I make the adoption and I have the adoption, I'm going to persist that in my database, and I'm going to put a record on the outgoing topic. Lots of different ways you could have designed it. That's just kind of how I designed it, just because I wanted to showcase how do you test that nothing happened is essentially the test case that I was looking for. So I kind of over-engineered the problem to be able to show that there's no, being able to test that something didn't happen, like an asynchronous event didn't happen. All right, so let's start. So I'm going to maybe I have it called adoption listener. So I'm going to say adoption listener tests, right? Again, this is Quarkus test, right? And then like before, I'll add some stubs here. Right, so I'm going to inject a spy, and I'll talk about that in a minute. So my adoption listener, which doesn't exist yet, I'm going to inject the mock for my repository, and then I'm going to inject a in-memory connector, which comes from the reactive messaging. So it's a way when I do testing, I could use a real Kafka broker and that would be fine. But just to kind of show this utility, you can swap out the Kafka with an in-memory channel rather than a real Kafka broker. And so that's what I'm doing, just because I decided to. And then I've got this, some things that don't work. And now I've also got this adoption request class. So let's go ahead and create some stuff here. So I'm going to create, I need this adoption listener class. So let's say create class adoption listener. Yep, so that's over here. I'll move that over here and make this guy application scoped so that he's a bean, right? And now I've got this adoption request object, which it still doesn't like for whatever reason. Still wants me to fix by it, probably because I haven't done this yet. So I'm going to create a constant field. Adoptions channel names. I like to use constants. I'll call this adoptions, and then I'll have another one later on. It still doesn't want me to do the IntelliJ assist is not. Let's see, fix with AI. What does it do? So I'm experimenting here. This isn't part of my script. Yeah, what did it do? It did something, but who knows what it did. All right, so my IntelliJ assist isn't working, so I'm going to come over here. I'm going to say a new record adoption request, right? Move this guy over here. And so I have a string adopted by and a string for kind, right? So now, I've got that record. All right, nothing else is read yet. So now we can go in and start implementing some of these tests. Yeah. So now I can say, I'm going to say when and then import that. I'm going to say when I adopt a pet if found. And I'm going to say my adoption request adopted by adoption request kind. Then return an optional of the pet that I created, right? So now when I want to adopt the pet, assume that there's a pet there and return Fluffy, Fluffy the cat that's up here. And so now I'm going to actually send the request to the channel. So I can say my in-memory connector, I can say my source is the adoption listener adoption requests channel, and I can say send the adoption request, right? So that sends the message to the channel. Now I need to wait for the messages to arrive. So let's create a sync var sync equals in-memory connector dot sync, right? So how would you wait for things to arrive? I mean, I could do like time unit dot seconds dot sleep, 30 seconds. So do you think that's long enough? Like you could kind of do this, and I've seen this a lot, but wouldn't it be better if your test just kind of waits a maximum timeout for something to happen? In that case, the something would be for the message to actually arrive in the Kafka channel. So this is where the awaitility utility comes in. So I can say await at most duration. I'm going to say 10 seconds of seconds or until some function returns to true. So my sync receives one message. Right, so now the whole test itself is going to pause and wait here for at most 10 seconds or until it receives one message. If it doesn't receive a message in 10 seconds, it's going to fail the test. If it receives the message before the 10 seconds, it'll just continue on. There are lots of other parameters you could use. You could tell it, how often it wants to check and whatnot. I'm just going to go with the defaults. And now I can say assert that sync received and import that is not null. And again, the received is a list. So I am asserting that it has one element and that one element is not null. I'm going to extract. It gives me back the message object. So I want the payload, right? And then another cool thing you could do with assert J is what's called recursive comparison. So I want to assert that in this case, it's a pet object, because my message listener is going to put a pet object on the topic, but the pet object, I want it to be the same as this pet object, but not the same object like in memory. So I just don't want to say like object that equals. I want to do it like a field by field comparison. So I could do like extract the fields and verify that they're the same, or assert J has this thing called using recursive comparison is equal to the pet. And so rather than comparing the identity of the pet or using like equals or hash code, it's actually going to retrospect or use reflection on the object and go field by field and verify that the fields are the same. So that's pretty cool. And then I could do some verification. I'm going to skip the verifications for now. All right, so let's see. And now, so like someone else said, I've got some other tests here that I'm just gonna kind of leave here. So let's go do. Oh, I actually want to do verify that my adoption listener. Remember, I'm doing a spy on my adoption listener. So verify that the adoption listener, the adopt pet if found adoption request adopted by adoption request.kind was called once. And notice that doesn't exist. So now I can say, okay, create that method. So now over here, it creates the method, right? So my string, adopted by, and then my kind. So now we can go implement this method until my test pass, right? So we need a couple of things here. So let's say, oops. So I need my, oops, not that one. So I need a couple of attributes. I'm going to say private, final. I need my repository, right? My pet repository. And then I need a way to publish to my topic. So I can say private, final, and in Quarkus we have this thing called an emitter that emits pets, and I'll call this the pet emitter. And then I'm going to use IntelliJ to create a constructor for me. And the only other thing I need to do is I need to now bind this emitter to a channel. So I can say channel is my adoptions channel, right? So now that the emitter is bound to the channel for the outgoing adoptions, I need to say transactional here, right? Because oh no, I don't need to do transactional here. And now I can just say this repository adopt pet found kind adopted by, and then I can say if present my emitter, I can say send, right? So if it found an adoption and recorded the adoption, then it's going to send to my adoption. And my tests still fail. Why do my tests still fail? Because I need to annotate the method here. Because now I need to say that this is an incoming, that the method is a listener for the incoming topic called adoption requests. And I'm going to make it run on a virtual thread, right? So now only one test fails, my adoptable pet unknown channel adoption requests. Yeah, that's because I haven't finished with the test implementation. But now everything should be good. So I guess we've got only like 5 minutes here. So let me come back to my slides. Here's my my slides here. So yeah, now things work. You prove it. You built a whole application, and we did it in just about 45 minutes. So there's lots of other resources that are out there talking about Quarkus, or in general. There's also, if you're not familiar with Quarkus, the Superheroes is the sample application. I'm also the primary maintainer of that. So it's a pretty comprehensive system of applications that have lots of different technologies in there, lots of tests. Yeah, and that's it. So any questions?
That's awesome, Eric. It was a great demo, and then hopefully a lot of people learn a lot of great stuff from Quarkus today. There are just some other question on that, except for many good compliment your demo and presentation. You might want to answer one interesting comment from Henry. He just added one comment for, is it not null, is it redundant? Here, because the is empty will also check for null.
Was that in the
some of your code? You can say, but I don't think is empty can check null.
Yeah,
multiple injection.
Yeah, it does check null as
It's
well. He's right.
Literally from the also that.
Yeah, he's right.
Yeah, just wanted to
Yep,
make
he's
some
right.
comment on that. Yeah. Alrighty.
Any other questions? So this again is a QR code for the slides. So takeaways: test-driven development is easy. It's not difficult. Assert J is awesome. Awaitility is awesome. Like for these, being able to wait for things to happen or to not happen. So some of these tools, and try to test the real thing as close to your developer environment before you check in any code as you can. Because like I said, that SQL query that I wrote, that would not work in MySQL or H2 or anything. So knowing your environment ahead of time would be great. It makes your unit test more more real, I guess, is the right word.
Alrighty. Thanks everybody joining and watching this great session today, and hopefully you enjoyed that. And then I spend a little bit more time with Eric with his prepare like a social media, X or Blue Sky and LinkedIn, whatever, any social media. And also Eric and I will be at JFocus Stockholm next week, but also many other like a Java conference, for example, Dev Nexus in the United States. To talk about any Java talks in there. So if you have any plan or chance to stop by that in-person conference coming soon, and then we more than happy to catch up with that.
Yeah, and I'll say too, you kind of see my contacts at the bottom here. The X has a red X in front of it. I'm actively trying to get off of X. It's kind of like strangling a monolith, because unless everybody does it, you still kind of have to be there. But I'm trying not to be there very often if I don't have to.
All righty. All right. Thanks again. And then have a good rest of the day. Bye.